Hi, good evening everyone, good evening. Good evening everyone, good evening. Good evening. Yeah, post everyone in the group. In the group also post. In the group also post. Good evening, good evening, good evening. Yeah, so I think we can move to the next problem. We can move to the next problem. I think you got some idea. You people got some idea. We can move to the next problem. Right? See this. See everyone. Next problem. So can you say today's date? Can you say today's date? Is it 18? 18/6/26. 18/6/26. Yeah, good evening everyone. Good evening. Yeah, I written already 18/6/26. So this problem already given. One problem I already given. Let's try one more problem. Let's try one more problem for BFT. Let's try one more problem for BFT. Right? Let me try. A, B, C, T, E, F, G, and H. So this is the graph. To this graph, careful everyone. With this problem, you should get the clear clarity of BFT. Clear clarity of BFT you should get with this. Give four different BFTs starting from H. Starting from vertex H. Starting from vertex H. So just give me 1 minute. Just give me 1 minute. How to do refresh? Fine. So now see this. Starting from H. If you want all the things, you can write capital. My intention is I want to write all capital. Nothing is there. A, B, C, D, E, F, G, and H. Yeah. Starting from H, right? Give four different BFTs. That is the goal. Now you people can try one by one. Try one by one. Starting from H, give four different BFTs. Starting from H, give four different BFTs. So I am trying now. This problem will clear it out all your doubts. This problem will clear it out all your doubts. I am starting. Four different BFTs starting from H. So I am giving first answer. Starting from H. H will be there. H adjacent is G only one person. G adjacent is F only one person. Till now only one answer. H adjacent only 1, G adjacent only 1, F adjacent as of now only 1. Now listen, F adjacent is 3 people, but 1 person already done. G already done. F adjacent is 2 people, A and E. Because of BFT, you have to write both the people. AE is one way. One more thing is HGF. So EA. Either you can write AE, either you can write EA. Now in the AE, A came first. These all are completed. So now I am at A now. Right? Because of AE, you written A first to A adjacent people. A adjacent people which are not done. I think BC. A adjacent people which are not done. Right? I think BC. F is already done. F is already done. So A adjacent is BC. So BC. You can write BC. You can write CB also. I written BC. Okay, fine. Now, can you help me? How many people are there total? Total, if you observe 8 people, already 7 came. 1 person left out D. You can write at the end. Total 8 people. 7 people already done. 1 person left out. Lastly, you can write. Now, let's see the second option. Let's see the second option. Let's see the second option. Can you see the second option? So in the place of AE, I written EA. So these all are done. Now I am at E now. E adjacent, if you observe, CF. E adjacent is CF. F already there. So C. E over. Let's go to A. Let's go to A. A adjacent is BC. C already there. So only B. I think 7 people are already done. Only 1 person left out D. So this is the one more answer. This is the one more answer. So 2 things done. Let's go to 3. Let's go to 3. HGF is common. HGF is common. So A, right? HGF is common. F adjacent is AE. I written AE. That is also okay. So till now, no objection. See this one. A adjacent is BC. Previously I written BC. Now I will write CB. So A completed. Let's go to E. But one thing I want to say to you, already 7 over 1 person left out D. Already 7 over 1 person left out, that is D. So let me know till now, do you have any objection? Till now, if anyone having any objection, let me know. Reddy Sir, I have objection. Let me know if anyone having doubt. If anyone say I have doubt, please let me know. 3 answers I already given. 3 answers I already given. But I want 4 answers. Can anyone give one more answer? Can anyone give one more answer? 4th answer, can anyone give? 3 answers I already given. Can anyone give 4th answer? Anyone? Can anyone try 4th answer? 3 answers already I done. Already I given 3. Can you give 4? Where is this Ankit guy? Are Ankit, where are you? Are Ankit bhaiya, kahan pe are aap? Ankit bhaiya, aap kahan pe? क्या यार आदमी नहीं coming यार, आदमी नहीं यार. Yes sir, okay. Oh, unnecessarily I shouted. Unnecessarily. I could have controlled myself. Ankit, sorry bhaiya. Ankit bhaiya, sorry. I am unable to see you. That is the reason I thought of taking one round. Thank you so much for informing now itself. Can you give 4th answer? Those people who completed, I want 4 answers. I given only 3. Can you give 4th answer? Marvel is came. Deraz is came. Attar is came. Amartya came. Sunny is came. Someone is saying HGF, AE, A adjacent is BC. Either you should write BC or CB. How you got the CDB, bhaiya? Are Marvel bhaiya, how D came yaar? Marvel bhaiya, how D came yaar? Either BC should come or CB. How D came in between Bhaiya? So let me try this. Let me try this one. HGF until now, see this one. Until here only one possibility. Okay, I am at F now. F adjacent is AE. F adjacent is AE. See this one. AE 2 times I already done. AE 2 times I already done. AE followed by BC. AE followed by BC. AE followed by CB. I already done. So the only possibility is, right, in the place of AE, EA. Let me try EA. If I try EA, F adjacent is AE, na? So I written EA. So until now, no problem. So F adjacent is EA. So okay. Now I am at E now. E adjacent is only C. So E completed. A adjacent is only B. Lastly D. I think this one both are same. This one both are same. Second option, fourth option same. I want 4 answers. 3 answers only done. One more answer is available. Can anyone try? One more answer is available. Can anyone try? 4 answers. 4 required. Someone is saying 4th not possible in this case. Arey Bhaiya, see the problem yaar. See the problem, Akhtar Bhaiya saying that 4 different BFTs not possible starting from H. How can you say yaar? See the question. Bhaiya. See the question yaar. So until now, can anyone give 4th answer? If you know BFT properly, can anyone give 4th answer? If anyone know BFT properly, can you give 4th answer? Everyone. Hello? Anjali Bhaiya kahan pe? Anjali Bhaiya, I think not there. Anjali Bhaiya, let's see. Yeah, came. Anjali Bhaiya there. Marvel Bhaiya there. Who is missing? Can anyone guess who is missing? 3 high ban pare. So 3 high ban pare. Means if you say in Hindi, do you think I don't get Hindi? Do you think I don't get Hindi? Are Ankit idiot? This Ankit person saying 3 high ban pare means, do you think I don't get Hindi? Are Ankit dog, do you think I don't get Hindi? So he written below also, translation also going on. First of all, why you written Hindi? Then why are you translating? Right, fine, perfect. And Anjali is saying that, sir, if gal na, then behan not Bhaiya. Thank you Bhaiya. Thank you Anjali Bhaiya. Anjali Bhaiya, thank you Anjali Bhaiya. Let's move now. Everything is perfect. Let's move now. Can you see the 4th one? Everyone see the 4th answer. Can you see the 4th answer? 4th answer starting from H, na? Starting from H. So 4th answer not possible. 4th answer is not possible. Okay, it is not possible. Thank you so much for trying. Those people who tried, thank you so much. Not possible. Nice attempt. Those people, if I say not possible, try, no one will try. If I say possible, try, then people will try. So I tried my level best so that you will try. So only 3 answers possible. Give 4 different BFTs starting from H. If anyone say it is possible, please let me know. I tried my level best to bluff you. To bluff you, I tried my level best. Problem saying 4, how can you give 3? I shouted also. Akhtar saying not possible. Akhtar, it is not possible for you. How can you say it is not possible to all? I blamed Akhtar also. Yeah, so for your convenience, right, to make it all right from your side, I given, it's okay. Give 4 different BFT starting from H, right? I think 3 possible, 4th one is not possible. Okay, fine. Chalo. Now listen. Now everyone listen. Everyone have to listen. For the first three, 1, 2, 3. For the first 3, 1, 2, 3, can you draw the BFT tree also? Can you people draw BFT tree also? Please draw BFT tree. I want BFT tree also. I want correct answers, draw BFT tree. Correct answers, draw BFT tree. I want BFT tree also. Everyone try. What is BFT tree for the first option? Second option, third option. Can you go ahead? Remember this, right? BFT is also known as a level order traversal. BFT is also known as a level order traversal. Can you see this one? See the graph. You have to see the graph. Don't see the answer. You can see simultaneously answer also, but major one is graph. See the graph. See the first option also. See the graph. See the first option also. H will be there. So H you write here. Okay. H will be first place. Okay, fine. Now H adjacent is G. G next place. Remember, if H is there in the first level, their adjacent is there in the second level. Now G is there in the second level, their adjacent will be there in the third level. Okay, till now no problem. So if the parent is there in the level 1, children will be there level 2. Their children will be there level 3. That is the reason it is called level order tree. Level order tree. BFT will generate level order tree. So BFT is also known as level order traversal. Now let's come to the F. Everyone observe now. F adjacent is 2 people, AE. But if you want, you can observe F adjacent is 2 people, AE. A also not covered, E also not covered. Remember, A first. A and E. But remember BFT follows P4, first in, first out, means Q. So first person take. BFT follows P4, means Q, first in, first out order. First person take. Now I am at A now. This is over. Now I am at A now. AE. Right? AE. Now I am at A now. So A adjacent what? A adjacent, if you see BC. A adjacent is BC. Remember, if the parent is there in the level 4, their children should be there in the level 5. So what is the answer now? Here BC. Okay, perfect. Now A completed, right? A adjacent is BC. I written BC. Okay, that is also fine. Now what about E adjacent? I want answer. What about E adjacent? A adjacent is BC, that's fine. What is the E adjacent? E adjacent is CF. E adjacent is CF. C already there. F already there. You no need to take again. E adjacent is CF. C already there. Right? F already there. No need to take. Because already covered. If you cover those people who are already covered, then it is called cycle. If you cover, right? If you try to cover some people who are already covered, then it will become a cycle. Then what is the meaning of BFT tree? Tree never contains cycle. So E adjacent is going to be CF. C already done, F already done. So simply ignore the E people. Let's go to B. So what is the B adjacent? B adjacent is D. B adjacent is D, which is not covered. That's it. B adjacent is D, which is not covered. Am I right or not? Yes or no? So Ankit is saying that E child D. Ankit saying that E child D. But arey bhaiya, in the graph also E child is not D. How in the BFT tree are? Ankit, E child is not D. Your child is D. Ankit, E child is not D. Your child is D. Not my child also. E child is D. No, E child is not D. E child is E, right? Your child is E. Are good. In the graph also, see this one. In the graph also, E child is not D. Yeah. C associated, D associated people are B or C. Chota Ankit bhaiya, true. So Ankit, not only you, many people will do this mistake. I know very well. No need to feel bad. So I want to make sure it is a big blunder. Some people are thinking that level by level I am writing. True. If they are adjacent, always you remember, if they are adjacent, then only write. And if they don't, create cycle. Remember everyone, if I am there in the level 5, level 6, my adjacent people there, if they don't create cycle, my adjacent means in the graph there should be an edge between them. My adjacent means in the graph between me and him there should be an edge. Many people will do this mistake. So please be careful. It is a BFT tree. So like Ankit, if anyone is done any mistake, rectify. I know this mistake will happen. So remember, I am not writing level by level. Level by level I am writing if adjacent. If I am there in the level 5, my adjacent people I will write in the level 6. If my adjacent, then only I will write level 6. If they don't create cycle, remember. Okay, perfect. Now what you do is second option. Can you draw the tree? Second option, can you draw the tree? Everyone try. Don't do small mistake also. I know mistakes will happen. That's the reason I given this. Go ahead now. Remember in the BFT tree, in the graph edge not there, you cannot create the new edge in the BFT tree. BFT tree is the subset of graph. It is not superset, subset. In the graph, so many edges. In the BFT tree, only n-1 edges. If n vertices, tree contain n-1 edges. Right? Tree always contain n-1 edges. N vertices, tree contain n-1 edges. Because no cycle. Start now. Everyone start now. Start from H. Okay. Next one G. That is also okay. Next one F. Till now, no issue. F adjacent is, see this one. F adjacent is two people, EA. But E first. A next. Now go to E. Right? Now go to E. Right? F adjacent is EA. Now go to E. So see the graph and talk. E adjacent is CF. See the graph. I am at E now. E adjacent is CF. CF. I think F already there. So CF. So only C will come. CF. F already there. So E adjacent is CF. F already there. So only take C. So E completed. Let's go to A. A adjacent is BCF. A adjacent is BCF. I think B not there. Okay. C there already. F there already. Only B. A adjacent is BCF. BCF. B not covered. C already covered. F already covered. So perfect. Till now, no problem. A also done. Let's go to C. Let's go to C. Who is the C adjacent? C adjacent is only D. That's it. This is the tree. C child D, A child B, E child C. Is it okay? Is it okay? Bro, is it okay? Right. If you comfortable, let's go to last one, third one. This is called BFT tree, which is also called spanning tree. BFT tree, right? BFT tree, that is okay. One more name is called spanning tree. One more thing is called spanning tree. If anyone asks you how to create a tree, if anyone asks you how to create spanning tree, simply on the given graph apply BFT. If anyone asks you from today onwards for the given graph how to create spanning tree, simply say do BFT traversal. Just to do BFT traversal, every BFT traversal will give one spanning tree. Purpose of BFT traversal, it will create spanning tree. Spanning tree also okay, spanning tree also okay, right? Spanning tree. In the algorithm, you may see minimum cost spanning tree. That is different. Simply spanning tree. Now come here. Now. Third answer. See the third answer. H will be created. G will be created. F will be created. Everything fine. HGF. Now I am at F now. F adjacent is AE. Okay. F adjacent is AE. That is fine. Now I am at A. Now. F adjacent is AE. Now I am at A now. Let's go to A. A adjacent is BC. Right? You can write CB also. CB. Let's check C available. No. B available. No. Okay, fine. So E adjacent. So A completed. Now go to then E. E adjacent. See the graph. E adjacent is CF. E adjacent is CF. C there, F there. So leave it. E adjacent is CF. C there, F there. Leave it. So after E over, go to the C. C adjacent is D. Right? It is the BFT tree. Are you okay? Fine. So yesterday this time they are very difficult. Now they are normal. Hello. Hi Taruni. Yeah, say. Those people who are new, if you are not getting, start from first lecture. You will get. If anyone is not getting, if anyone is new, if you are not getting, first lecture onward check. Graph traversal, first lecture onward check. Okay? Sunny and Taruni, right? Please check both. Right? There may be, I think, because of the first lecture, you may be, because of you are in the middle, you may not get fully. Yeah, you can start from after today's class over, right? Start from first lecture. If you are getting now, continue and complete the previous things. If you are not getting, first lecture onwards start. Start from first lecture onwards. Graph traversal 1, graph traversal 2, graph traversal 3. It is the fourth one. So because of 3 lectures are over, some basics are missing, right? You may not get it. Start from 1 onwards. Make sure you will catch as soon as possible live. Take it as a challenge. Right? Finish it off as soon as possible. Right. From Monday onwards, classes will be there in the EPT platform. Okay, fine. I think you people are comfortable. Now we can move to the next story. Can I move to the next one? Can I move to the next one? BFT clear? No requirement of one more problem? No requirement of one more problem? BFT I think clear. BFT I think clear. No requirement of one more problem. Right? We'll go to the DFT. We'll go to the DFT. Right? We'll go to the DFT. I think BFT clear everyone. Everyone BFT clear. If you clear with the BFT, now let me go to the next story. Right. Let me go to the next story. Yeah, so it will take 1 or 2 minutes. Let me finish it up. In EPT, all classes are in English only. Live classes there, recorded classes are there. Daily quizzes also there. Right, doubt solving is there. PYQs also there. Mentorship session also there. So we will give the planning also. So these are the EPT rankers. I want to see next year your photos also here. Next year I want to see your photos here. I want to see next year your photos here. These all are EPT students, right? You can next year I want to see your photo here. And one more, if you are there in your college, if you are a college going student, if you are there in the college top five, if you are there in the EPT Rise 1000 initiative, you can get the subscription almost freely. You will get the subscription. Just the platform fees 2000 rupees you have to pay. If you are there in the top 5 of your college. Right, in the EPT, right, Rise 1000 initiative, you can get the admission freely, either placement course or gate. You will get it freely, almost freely, just platform fees you have to pay. Next one is going to be DSA Super 300 is going on. Please, 300 good problems will be solved for DSA purpose. You people can join. Right, so some surprise is going on, right, Monday. So you people can see that. Now, if you selected for any company, right, interview purpose, if you select interview, so mock interview we will provide freely. Please inform to us. So these are the EPT teachers. All the teachers, if you see, they are all are experienced people and rankers. Now, C programming is free in the YouTube. Please verify. Python programming also free in the YouTube. You can verify. So you can take whatever course if you want, if you are serious for the preparation. So every Saturday, Sunday, there is a mentorship session. You can join and you can get the targets and all. So 6,000 verified questions, 3,000 gate PYQs, AR1 handwritten notes, doubt solving, all will be freely available on the website. You can go through it. These are the EPT students, right, who place in the big companies. So these are the right EPT placement courses, DSA placement course, right, DSA course, DSA plus system design, DSA practice courses, mock interview courses, programming languages courses, full stack course, full stack web and app course, front end course, C programming and Python free. You can see that. Yeah, thanks for your cooperation. Right, now come to the story. Now come to the story. Now listen. Listen everyone. Everything is clear. Now listen. Important points about BFT. About BFT, some important points. BFT important points. Yeah, see this one, BFT important points. First point, BFT uses Q, which is first in, first out. Okay. Second, while doing BFT, if it is a graph, total graph you have to visit one time. So time complexity, order of V plus E. Time complexity, order of V plus E. Time complexity, order of V plus E. Right? Now go to the 3. So why order of V plus E? V vertices are there, E edges are there. V vertices and E edges are there. V vertices and E edges are there. To cover the total graph, time complexity V plus E. Right? Time complexity V plus E. This point also okay, fine. Next one, BFT is also known as level order traversal. BFT is also known as level order traversal. Next one, fourth one. Space complexity of BFT is equal to space complexity of BFT. Right? Remember, space complexity of BFT is equal to, everyone observe. Everyone observe. Space complexity of BFT is equal to, right? Listen carefully. Space complexity of BFT. First of all, what is the meaning of space complexity? Space complexity means, right? Carefully, everyone. Extra space. How much extra space you are taking? Right? Space complexity. That means how much extra space you are taking. If you see the extra space, otherwise you can write this also. Space complexity. Input plus extra. So input purpose, right? You are taking V plus E. Total graph you have to take. Plus extra, if you see the extra, I think if you observe clearly, one widgeted array you are taking. One widgeted array you are taking. Right? Be careful. Extra space. They may ask you clearly extra space. If they say extra space, go for extra space. I will write here itself. You will get clarity. Input is graph you have to take V plus E. Extra space if you observe, clearly, so one queue you are taking, that queue size is V vertices. Next one widgeted array purpose, for every vertex purpose one slot, right? That is V. Widgeted array purpose one array required, queue purpose, right? One array also required. If anyone having small doubt, I will show to you. This is the queue. See the queue. This is the queue. Everyone see this. This is the queue. So every vertex is going one time only inside. Every vertex going inside one time only. See, A went. Next B, C, D. Next one, right? Afterwards E. Only new people are coming. F. Next one G. Lastly G also. All the people came one time. So maximum space it will take V only. Some people are asking, where is the widgeted array? This is the widgeted array. For every vertex one slot. For widgeted array one queue. Don't remember, this total is one queue only. I am showing slot by slot. Step by step I am showing, but only one queue there. In that queue, right? Maximum space required is how many vertices are there? Those many, because same vertex cannot go many times. So come here. So space complexity of the BFT algorithm is going to be input plus extra. Input is graph you have to take V plus E. Extra, queue purpose V. Widgeted purpose V. Total space if you observe, right? 3V plus E. So constant doesn't matter. Space complexity big O of V plus E. Right? Big O of V plus E. Extra space, if they ask you extra, give this. Only extra 2V. Total space 3V plus E. 3 is a constant, you can ignore. So space complexity big O of V plus E. Are you comfortable till now? Why time complexity V plus E? Covering total graph one time. Fine? Is it okay? BFT important points. Uses Q. Time complexity V plus E. Sir, here E is extra. Where is E is extra? V plus E for graph. Graph given means vertices given, edges given. Graph given means vertices given, edges given. What is the space complexity? Total space you are using. Total space you are using, input plus extra. Input plus also you are using, right? Whatever space you are using, input purpose V plus E space, extra is going to be, right? V for the Q, V for the widgeted array. Totally 3V plus E. Finally, big O of V plus E. Okay? These points are okay? Sir, my doubt, please. What is your doubt? Yeah, so I have to say that one. That is the reason I request everyone. I request everyone. Everyone I request. I request everyone. It is there. It is there in the, right? It is there in the algorithm. It is there in the algorithm. Otherwise, it will take some time, right? I will explain that also. It will take some time. I will explain that also. Please listen them. Because of Ankit is asking, I am covering that point also. Some redundancy, I am covering that point also. See this. If everyone listen. Graph representations. How to keep graph inside computer. Graph representations. It is already there. It is already there in algorithm. It is already there in algorithm. It is already there in algorithm. Total graph story there in the graph theory discrete mathematics. It may be repetition. It may be repetition. It may, in the editing, I will delete it. Because there are some people are here who don't know graph representation. For them, I am explaining this. For them, I am explaining. Otherwise, I may not explain this. Listen, everyone. Graph representations. So, to represent a graph, there are two ways are there. To represent a graph, there are two ways. One is adjacency. One is adjacency matrix. To represent a graph, one way is adjacency matrix. One more is adjacency list. To represent a graph, there are two ways. Adjacency matrix, adjacency list. Just see one time, nothing there here. Very simple it is. Suppose assume it is a graph. Assume it is a graph. Just listen, everyone, assume that it is a part of it. See, it doesn't matter where you learn. Learning or not, that is important. Learning or not, that is important. Graph representation. Because Ankit is asking something, right? That for that purpose, this point is required. Graph will be represented inside computer. There are two ways. Adjacency matrix, adjacency list. See the graph one time. It is a graph. It is a graph. Assume. This is the graph. Now see what happened. So this graph inside a computer, how will you represent? So there are 5 vertices, write 5 rows, 5 columns. There are 5 vertices, write 5 rows, 5 columns with the vertex names A, B, C, D, E. 5 rows, 5 columns you do. 5 rows, 5 columns. Okay, fine. Right? Remember how you represent this graph. This graph to represent one way, adjacency matrix. Okay. So how many vertices are there? Those many rows, those many columns you write. Those many rows, those many columns you write. Suppose 5 vertices, 5 by 5 matrix. If at all 5 by 5 matrix. If at all 10 vertices, 10 by 10 matrix. If at all n vertices, n by n matrix. N by n matrix. Try to understand. Next one. Now see, some people are asking, sir, how, sir? Can you go there? Right? A to A edge there. Edge I am talking. A to A edge there? No. No self loop. A to B there? Yes. Edge there, keep 1. Edge not there, keep 0. A to A, no, not there. A to B, yes. A to C, yes. A to D, no. A to E, no. Edge there, then only keep 1. Otherwise, keep 0. A over. Let's go to B. Let's go to B. Let's go to B now. Right? Next one. B to A. B to A, yes. A to B, B to A, both are same, yes. B to B, self loop not there. B to C, yes. B to D, yes. B to E, no. Let's go to C. Let's go to C. C to A, yes. C to B, yes. C to C, self loop not there. C to D, yes. C to E, no. Let's go to D. Let's go to D. D to A, no. D to B, yes. D to C, yes. D to D, not there. D to E, yes. Let's go to E. So E to D only there, remaining all zeros. So to represent graph inside computer, one way is matrix. So I think some people are asking, sir, how matrix? You know very well. Those people who know C programming, in the C programming, how you take matrix, you know, array, just a 2 by 2, right? A 2-dimensional array required, you have to write like this one. Int, suppose isn't that this matrix name is M. M is equal to this. So int M of 5 rows, 5 column. If you do like that in the C programming, then you will get the array. Or 2D array, you will get 5 rows, 5 column. While writing C programming, if you declare like this, one matrix will be allocated like this. So adjacency matrix. So to represent this graph, some people are thinking, some students are thinking that this graph inside computer will store as a graph only. This graph inside computer will store as a graph only inside computer. No, it will store as a matrix. Like this it will store. Inside computer, that graph will store as matrix. Right? 2D matrix, 2D array, 2D array. Sir, how I know? Sir, how I know C and E are adjacent or not? If you give this matrix, how I know C and E are adjacent in the graph or not? Very simple. C and E, 0. So not adjacent in the graph. Whatever you can do in that graph, same thing you can do in this matrix also. Same. I think I want to check BC. BC adjacent or not? See, BC. See, adjacent. I want to check BE adjacent or not? BE adjacent or not? No. So what I mean to say is, inside the computer, graph will not store as graph. Inside computer, graph will store as a matrix. Then how you take matrix inside computer? 2D array. Inside computer, I will take graph in the form of a matrix. How you take matrix? Or a 2D array. Everyone know, whoever knows C programming, they know very well about arrays. How to declare array in the C programming, everyone know. Every language, C language in one way, Java language another way, Python language another way. Every language to take array, some provision is there. Indirectly, directly to take array, some provision is there. Now, to take this graph inside a computer, one is matrix, another one list. Some people are asking, what is list, sir? Can you see this? Can you see this, everyone? Can you see everyone? Everyone observe here. How many vertices are there? Take in the form of one array first. It is a 1D array. Take one 1D array first. How many vertices are there? Take one 1D array. Okay, I took. It's a 1D array. I may be written this 1D array in the vertical direction. Normally, array will be written horizontal direction. It's up to you. You can represent the diagram whatever way you like. Right? It is a 1D array. Right? Take one 1D array, where in that 1D array, all vertices are there. Now observe what happened. Who are the A adjacent? A adjacent is BC. Then what you do is, A adjacent is BC. First write B. Next write C, BC, A adjacent is BC. B purpose create one node, C purpose create one node. Let me ask you, address of this one is 1000, this node, address of this one is 2000. Right? Listen everyone now. Address of first node is 1000, address of second node is 2000. Right? See, first node pointing to second node means first node next is second node, 2000. Now listen, A adjacent, how many people are there? For all of them, create one linked list. That linked list you store in A. What is the meaning? Linked list storing means storing first node address. This address I will store here. A contain whoever A adjacent. They all are there in the linked list. That linked list is there with A. Sir, last node, what is the last node next, sir? Nothing is there now. So that is the meaning of adjacency list. List means linked list. It is a linked list. Linking going on. That is the reason it is called linked list. Next one. Whoever is B adjacent. Who is the B adjacent? B adjacent A also, C also, D also. B adjacent is A also, C also, D also. So just give some addresses. It is a 3000, it is a 4000, it is a 5000. So further no one is there, none. So 4000 next is 5000. 3000 next is 4000. Right? I think B pointing to this linked list means first node address. Next one. Whoever is C adjacent, keep all of them in the linked list and check, connect it. C adjacent, A, B, D. A, B, D. So anyhow, you will get clarity about the linked list in the linked list chapter. Don't worry. Next one. D adjacent who? D adjacent what? B, C, E. B, C, E. B, C, E and none. Right? Next one. Who is the E adjacent? E adjacent is only D. So let me give addresses only for namesake. It is a 6K, it is a 7K, it is a 8K. It is a 9K, it is a 10K, it is a 11K, it is a 12K. Further no one, none. So remember to represent a graph two ways. Matrix format, list format. What is list? A adjacent people keep in the linked list and connect. B adjacent people keep in the linked list and connect. C adjacent people keep in the linked list, connect. Linked list, sir, I don't know much. Linked list chapter you will see. Roughly I written. E adjacent is only D. E adjacent is only D. Now observe. Everyone observe. See this one. Everyone observe. To represent a graph which contain V vertices, if you want to visit that particular graph which contain V vertices in the matrix format, total matrix you have to visit. Total matrix, what is the meaning? N by N. Right? If at all V vertices, V by V, which is going to be V square time. V rows, V column. Everyone you have to visit. If you want to visit that graph, you have to visit this total matrix. Right? Next one. If you want to visit this graph in the form of list, see this one. This is V time. This is E time. So totally V plus E time. In the list, if you want to visit the graph, V plus E time. Vertices you have to visit. Their list also you have to visit. List contain number of edges, how many there? That much. Approximately 2E. So now come back. Ankit asked a nice question. That is the reason I came here. Time complexity V plus E, if at all graph represented in the form of a list. If graph represented in the form of a adjacency list, V plus E. If graph represented in the form of a matrix, V square, adjacency matrix. Write this. Right? So total graph to visit in the list V plus E time. In the matrix order of V square. Are you okay? Can you check? To scan the entire graph, if matrix format, total V by V matrix you have to scan, which will take V square. List if you see normal. Vertices purpose V, edges purpose is E. V plus E total time. Total matrix to total graph to scan V plus E time. Here to scan V rows, V column. V into V, V square. But remember, inside the computer, there is no graph. Graph will be either like this. Now understand. Now understand. Can anyone help me? Can anyone help? Can anyone help? Careful everyone. Can anyone help? If you observe the list 2, see this one. If you observe list 2, E adjacent is only one person. See this one. E adjacent is only one person. Only one person there. Write only one person. E adjacent is only one person. If only one person there, write only one person. You no need to write extra. If at all A adjacent to two people, if two people are there, write only two. If one person there, write only one. If two people there, write only two. If three people there, write only three. If three people there, write only three. In the list two, how many people are there? Those many people only I will show. But in the matrix, see this one, in the matrix, E adjacent is only one. But you have to write all. The only thing is, not there people, 0 you have to write. There you have to write 1, not there you have to write 0. Here every time you have to write. E adjacent people 1, still you have to write all. Right? Next one, D adjacent is 3 people, still you have to write all. C adjacent is only 3, still you have to write all. B adjacent is only 3, still you have to write all. A adjacent is only 2, still you have to write all. In the case of matrix, either there or not there, you have to write everyone. You have to write everyone. That is the reason at the V square time, all the people you have to represent. But here, there you write, otherwise you don't write. That is the reason whenever someone say graph given by default list only. Graph given, if you don't mention by matrix, go by list only. If you don't mention by, right, if you don't mention graph is given how, they didn't mention, go for list, because list advantage is how many people are there, those only you will show. You don't show extra. You don't show less, you don't show extra. How many there, those many only you will show. But in the case of matrix, there are not there. You have to show everyone. Right? In the exam, if you don't mention anything, matrix or list, by default list you can go. By default list you can go. Because if they mention matrix V square, because total matrix to scan V square time, if anyone is not getting, this thing in algorithm I said very clearly. This thing I said in algorithm very clearly, don't worry. So many problems also I covered. In algorithm, this one I covered, right? I given 10 problems also. Because of this Ankit asked. That is the reason I covered. Otherwise, I don't cover here because already there. Right? Already there. Don't worry. Just roughly I covered. So graph will be represented how many ways? 2 ways. How? Matrix format, list format. Right? Matrix format and list format. So matrix how? Roughly I explain like this. List how? Like this. Matrix is like this, list is like this. So which one having some extra space? I think matrix. Matrix, what happened is not there also you have to represent, there also you have to represent. In the case of list, there then only represent. Otherwise you don't represent. Right? So in the case of matrix, every time I have to represent. In the list, there represent, otherwise don't represent. By default, list. By if they don't mention anything, list. So list, total list scanning, how much time? V plus E. V for vertices, E for edges. V for vertices, E for edges for list, matrices V square. Yeah. So if everyone says, sir, we are comfortable. If everyone say you are comfortable, then I will move next one. Can you type? If anything you are not getting, let me know. Sir, this is not okay, sir. Let me know. Yeah, what about space? I think space also same story. Right? Input is V plus E for list 2. For matrix V square. So list, let us assume that list 2. So to represent the total graph, right, in the case of the matrix, V square, but in the list V plus C. So I am writing. If not mentioned, then take, adjacency list. Now, one small question I want to ask you. One small question. I don't know how many people will give. Sir, two ways are there. If they don't mention, you are saying list. Sir, actually two ways are there. If they don't mention, you are saying take list, because list people don't take more, don't take less. How many people are there? It will take those many. That's okay. Then what is the purpose of matrix, sir? Can anyone help me? I think matrix is better for complete graph or not? Matrix is better for complete graph or not? Can anyone help me? Matrix is better for complete graph, or in the complete graph, everyone is adjacent. In the complete graph, everyone is adjacent. In the complete graph, everyone adjacent. A adjacent all, B adjacent all, C adjacent all, D adjacent all, E adjacent all. So if the graph is a complete graph, right, matrix better. Right. If the graph is a complete graph. If graph is a complete graph, means no gap at all. If no gap at all, then go for matrix. Suppose more gaps are there, go for list. If more gaps are there, go for list. If no gaps are there, go for matrix. So I am writing. If complete graph, then adjacency matrix better. Next one, if null graph, more edges. If more edges, go here. More edges. Next one. If less edges, something like null graph. Less edges, something like a null graph. Then go to adjacency list. Right? So less edges means, right, less edges, which is also called sparse graph. Less edges means sparse graph. More edges means a dense graph. So technical words, can you remember? More edges means, remember, more density. More edges means more density, dense graph. More edges, dense graph, then something like complete graph, then adjacency matrix. Less edges, which is called sparse graph, right, means something like a null graph, then go for list. Suppose nothing is mentioned. If not mentioned, then take adjacency list, because adjacency list advantage is how many there, that much it will take. Adjacency list, what it will saying is how many people are there, those many people I will take. Right, sparse graph. Yeah, link list will take care, right? Link list will take care. There we will see more clearly. Don't worry that much. Yeah, whatever you are saying, Sunny, you are correct. But in algorithm subject, clearly I mentioned, I don't want to waste your time again. I don't want to waste your time again. In algorithm subject, clearly mentioned. I took almost like one class, 4 hours class I took. 4 hours class I took. This is only for sample. This part is only for sample. Please take care from here. Roughly I explained. Roughly I explained. Right? This one is there in the algorithm. Remember, this is there in the algorithm. You can revise again there. You can revise again there. You may say that in the algorithm where? In algorithm where, sir? Whenever spanning tree chapter is going on, minimum cost spanning tree going on, there I explained. In the algorithm, whenever minimum cost spanning tree is going on, there I explained. But anyhow, roughly I given. If you can get, well and good. If you don't get, also no problem. Check. Try to get your level best. Try to get your level best. More edges. See, more edges. More edges means this total matrix required. More edges means this total matrix required. This total matrix required V square. So less edges means I think less will come. Right? Fine. Can we go further? So 3 points I am writing. Let me mention the 3 points. It is a number 1. 3 points. It's a number 1. It's a number 2. It's a number 3. More edges. Remember, more edges means more density. More edges means more density. Remember. Right? Sparse graph. If graph contains less edges, something like a null graph, then adjacency list is better. Right? Sparse graph. Right? Fine. Now come back and see. BFT important points. Uses Q. Time complexity V plus E. For the list 2. For the matrix V square. Next one. If they don't mention anything, first one follow. I didn't mention anything, so I written the first one. Next one. BFT is also known as level order traversal. Space complexity means input plus extra. Input, how the graph is given. List or matrix. If list, V plus E space. Right? V plus E space. Time also same, because to cover the total graph, V vertices, E edges you have to cover. Right? So input is going to be, right? If at a list format input given, V plus E. If it is matrix format, then V square. Extra space, Q purpose V, widget purpose V. Totally 3V plus E. Finally, big O of V plus E. Right? So 3V means 3 is a constant, you can ignore V plus E time. V plus E space. If matrix, I am writing that also. If matrix, V square for the input, 2V for the extra. Totally V square plus 2V. So I think V square is far bigger than 2V, so V square. Finally, V square. This is for matrix. Right. Clearly, the story is there in algorithm. One more time, you can check there also. I am saying the space also, minimum cost spanning tree in algorithm. Before starting that story, I explained everything. So nicely I explained. So deeply I explained, not normal, so deeply. This itself, if you feel deep, you see that one, you will see more deep. That is more deep. Right now, can I move now? Can I move now? Bro, can I move now? Say everyone. One person doubt also there, let me know. One person also doubt there, you can ask. Small doubt also there. Sir, I didn't get this point. You ask me, I will help. One person also. Whoever is not commenting, everyone have to comment. Say yes or no. Sir, this point not okay. Everything okay. You say, we will go further. Where is Anjali? Where is Anjali? Isaac is there. Akhtar is there. Auxiliary means extra. Auxiliary space means extra space. Auxiliary space means extra space. Right. Now let's go. Anyone having small doubt, let me know. Small doubt also. Yes. All adjacent should be there in any order. All adjacent should be there in any order. Adjacent people all should be there in any order. See, B, C. You can write CB also. Any order you write. Next one, B adjacent is A, C, D. Any order you write. C adjacent is A, B, D. Any order you write. D adjacent is B, C, E. Any order you write. E adjacent is right. D null. Right. Only one that nothing is there. Right. Fine. Now, so I given two homeworks. Everyone listen. I given two homeworks. I given. So whatever graph things required here, I covered. Total graph story if you want. In discrete mathematics, there is a portion called graph theory. In the discrete mathematics, there is a chapter called graph theory. Please study this. 5 lectures are there. You will get the approximately 2 to 4 marks you will get. If you want, right? Gate people, my request is, before completing this data structure, you please complete in the discrete mathematics graph theory. 5 lectures are there. 2 to 4 marks you will get. That is one assignment to you. Whenever you will get time, please do it. Discrete mathematics graph theory. Sir, if complete graph, then it will be. Then what is that n into n minus 1? See correctly. In the matrix, right? At that time, you have to show maximum all ones. Mostly all ones are there. If complete graph in the matrix, mostly all ones are there. Right? Okay. So because of Amartya is asking something. I will clarify. Because of Amartya asking something, I will clarify. Careful. I will clarify. It will disturb other people. That is the reason I am just avoiding. But anyhow, because of he is asking, you can see here. Right? Complete graph. Can you help me now? Suppose assume it is a complete graph. I am expecting answer from everyone. Assume it is a complete graph. So, how much space required for a matrix? Say everyone. Because some people are asking, Sunny also asked the same. Ankit also asked the same. Amartya also asking same. So, let's clarify that also. Assume given graph is a complete graph. In the matrix format, how much space? Please go ahead everyone and give answer. How much? Given graph is a complete graph. Assume 5 vertex complete graph. How much space for matrix? 25? 5 rows, 5 columns. 25 bytes. Assume it is a 5 vertex complete graph. Okay? or 25 bits. 5 5s 25. 25 bits because 0 or 1 you are representing. 0 or 1. 0 or 1. 0 or 1. 25 bits. Suppose assume to represent 0 or 1 byte space you are taking. 0 also 1 byte is you. 0 also 1 byte is you. 1 also 1 byte. In 1 byte you are representing 0 or 1. Assume. Actually 1 bit enough. Let us assume that byte. So 5 5s 25. 25 bytes approximately. Now come to the list. Everyone observe. Come to the list. Come to the list. For OTCS purpose, 1 byte. A purpose, B purpose, C purpose, D purpose, E purpose. So it is going to be 5 bytes. And edges purpose, if you see, if it is a complete graph, 5 OTCS, here 4 will be there. Right? Here 4 will be there. Here also 4 there. Here also 4 there. Here also 4 there. So how many times? 5 4s 20. But remember everyone. But inside, if you observe that every node means, what I mean to say 20 nodes are there. 20 nodes at this level. 20 nodes are there. But every node, if you observe, 2 bytes. 1 byte here, 1 byte here. Every node contains 2 parts because it is a linked list. 1 byte here, 1 byte here. So into 2. Totally 5 for OTCS. Right? Now, if you see the second level, number of nodes, 5, right? There are 5 linked lists. Every linked list contains 4 people. 5 4s 20. Every one is 2 bytes. 20 into 2, 40. So 45 bytes required. Is it okay? Is it okay? A linked list contains 4 people if it is a complete graph. B linked list contains 4 people if it is a complete graph. C linked list contains, right? C contain 4 people. D contain 4 people. E contain 4 people. 5 4s 20. Everyone is 2 bytes. Everyone is 2 bytes because it is a node. It is not one element. It is a node. It is a node. 20 nodes are there. 20 nodes are there. I am talking about a complete graph. 20 nodes are there. Every node is 2 bytes. So 45 bytes, but here only 25. So complete graph, matrix better. List 2, right? Null graph, something like null graph, list better. Nothing is mentioned. Go for list only. Go for list only. Thanks for asking. Thanks for asking. Some people may not get it. It's okay. You see in algorithm subject, I am repeating once again. See in algorithm subject, clearly I mentioned. So carefully I written all the points also. All the points also I written carefully. See, he is saying, Are Ankit, you don't know what to talk also. That much common sense missing. Now he is saying array of pointer. Then I have to go to, once again, what is the pointer? Common sense is there. Then actual topic is diverting. Then I have to say, someone will say what is a pointer, because they may be not studied the C programming. They may not studied the C programming. You want to torture the people, right? Otherwise, here only we are dancing. Fine, perfect. Now let's come to this point. Let's conclude. Nothing is there. Let's conclude here. Important points. Everyone listen. Everyone, nothing is there. Don't think much. I want to make as simple as possible, but some people asked. If it is valid, I want to give the explanation I given. See, BFT important points. First one, uses Q. Next one, time complexity. Total graph to cover. It's very simple. One scanning only. So matrix V square, list V plus E. BFT is also known as level order traversal. Next one, space complexity, input plus extra. What is the input? How graph is given? List V plus E. Extra what? Q and widget array. Q purpose V, widget array purpose V. Totally 3, right? Totally 3V plus E. Finally V plus E. If it is a matrix, If it is a matrix, input is matrix format, okay, V square. So same story remaining. V for Q, V for visited array, totally V square plus 2V. Finally, bigger one is V square. So time complexity V square, space complexity V square matrix. This is the extra stuff. This is the extra stuff. Whatever you got, that's okay. This is extra stuff. Because of Ankit, this is dedicated to Ankit. This shit is dedicated to Ankit. Dedicated to Ankit Pig. This story is dedicated to Ankit Pig. This is dedicated to this 45, 55 dedicated to Amartya. This is dedicated to Amartya. This 45, 25 dedicated to Amartya Bhaiya. Okay, fine. Can we move? So very simple, very simple. This also let me summarize. It will be useful to you. Afterwards, you can study more deeply also. Let me conclude. Graph representations are two types: matrix, list. Matrix like this, list like this, matrix like this, list like this. Now come here. If nothing is mentioned, go for list. Because list advantage. It don't keep more, it don't keep less. How many people are there? It will keep those many only. But there is some extra burden here, right? Because of it is a linked list, links are there. That is the extra burden. But the beauty about the list is, how many people there? Those many people only will keep. See, E adjacent is one person, one only will write. E adjacent is one person, E will write V. E adjacent is one person, E will write V. But here, E adjacent is one only will write, but some extra burden in the form of links. So list advantage is how many people, that much only they will keep, but little extra burden also there. So most of the time list better. If complete graph, matrix better. So less edges means something like a null graph, which is also called sparse graph. Then adjacency list better. If more edges, something like complete graph, which is called dense graph, then adjacency matrix better. Nothing mentioned, then go for list. So this Sunny saying me too. This space place, not only Amartya, Sunny also there. Two dogs are there. These two dogs are talking about those pointers. Extra space is extra space is taken care by these two dogs. Two pigs for the extra space. Okay, now are you happy? Now let's move to next. See, 1 hour is wasted. Ankit, you said one line. You said one line. Adjacency matrix V square. You said one line adjacency matrix V square. 1 hour is wasted. 1 hour, literally 1 hour. I escaped also. Then he once again dragged me. Sir, you didn't give my answer. This dog is given one line also. You didn't clarify my answer. Right? This dog is saying, I ignored first time. I know it will take half an hour or 1 hour. I know this. That the reason I ignored. This dog said one more time. Saying that you ignored my question. Then I got to know 1 hour will be wasted. Right? Anyhow, it's not a waste. It is not a waste. I think it is a recollecting again. It is a recollecting again. I don't ask doubt. You will say like this, but you will ask, I know very well. I know very well about you. I know very well about you, Bhaiya. Right, now come back. Everyone. Everyone come back. Now come back. Fine. See this. See this? Yeah, listen this also. Listen this also. A, B, C, D, E, F, G. One graph is there. Everyone try to catch this also. This point also try to catch. And one more thing. Anyone having any doubt, you can revise again. Right? It's not a big deal. It's not a big deal. Some doubt is there. Some doubt there. Revise again. Some doubt there. Revise again. You can ask in the group also. This is how people will grow. You want to grow in life. You want to grow in life. Do something. You will get some doubt clarified. Right? So little doubt also there. You can see once again. And one more thing, in algorithm also it will come. Don't worry. So if you escape here also, there also you will get. Right? Now come here. A, B, C, D, E, F. E, F, G. So it's one important thing. Careful. Careful everyone. I am talking about DFT. I am talking about DFT. Can you see this? DFT of V inside. DFT of V inside. Understand? First one. You will get clearly. You will get clearly. Someone is saying Telegram is banned. So I given right WhatsApp link, right? I given the WhatsApp link also. Am I given WhatsApp link? So this is the number. If anyone is not there in the WhatsApp, ping me. I will add you. Right now see this one. I want to explain with the help of this problem how DFT work. How DFT works, right? I want to explain here. Can you help me now? DFT uses stack or not? DFT uses stack or not? DFT uses stack or not? Next one. Recursive program uses stack or queue? Recursive program uses stack or queue? Recursive program uses stack or queue? A function calling itself is known as recursion. A function calling itself is known as recursion. Stack. So it is a recursive program. See this. DFT calling DFT. DFT calling DFT. Right? Now I will explain. I will execute now how it is working. How it is working, I will execute. Everyone listen. I give in the numbers also. Everyone listen. It is 1, it is 2. Inside, if anyone come inside, for loop inside if you come, it is 4th line, it is the 5th line. It is a 4th line, it is the 5th line. If 4th line is true, then only 5th line. 4th line true, then only 5th line. You know DFT already. I want to give how it look like inside. How stack is using. I want to show to you how it look like inside. Without this program also, you know DFT, but this program will give much clarity. This program will give much clarity, right? So one time let me execute. Everyone observe. One time let me execute. I'm starting. So this program contain 5 steps. 1, 2, 3, 4, 5. This program contain 5 steps. 1, 2, 3. Right? Inside 3, 4, 5. Inside 3, 4, 5. Right? If you don't want to give numbers also, okay, fine. Yeah, I think 5 steps. So I'm starting. Everyone, one time listen. 5 steps are there. First two. See this one. First DFT of A is called. Starting from A, DFT of A is called. So V means A. Remember, I will use another color also. See this. One time listen. DFT of A. So V is A. And one more thing I want to say to all the people. Visited of every vertex initially 0. Visited of every person initially 0. Visited of every person initially 0. A here, B here, C here, D here, E here, F here, G here. Visited of every person is initially 0. Understand this. One time listen, one time. Without this also no problem. But when you have much clarity, you will remember many days. See this one, DFT of A. See the first step. Visited of A is equal to 1. Okay. Second, print that. I am printing the answer. Print it. A printed. So first step is completed. Second step is completed. Now let's go to third step. See the third step, everyone. For all W adjacent to V. So adjacent to A, how many? B, C, D. For all W. So remember, W is equal to all adjacent of A, B, C, D. W is B, C, D. Remember, for loop is going. Third step is for loop. So remember, this third step will run 3 times because 3 adjacent people. First W is this. Second W is this. Third W is this. For all W adjacent to A. Adjacent to A is BCD. So this is the first W, second W, third W. Take first W, which is B. Take the first W, which is B, then execute the 4 and 5. Can you see this one? What is 4? What is the 4? First W is B. What is the 4? If B not visited, first W is B. First W is, otherwise I can say W1. First W is B. So if B not visited, see the fourth step. If B not visited, of course, B not visited, see. B not visited. If not visited, then only call because of not visited. Then fifth statement is saying call. What is the call? DFT of B. W1 is B, na? DFT of B. It is a recursion. Listen, it is a recursion. Recursion means same story again. Remember, to complete fifth one, I should do this much work. See this one. Whenever DFT function is called, you have to execute 5 things. 1, 2, 3, 4, 5. So to complete the 5, I have to call DFT of B. So remember, first A called, A pushed inside stack. See, remember it is a stack. In the stack, first unit, A is available. A is waiting. Because A is not done fully. Because this loop should be done 3 times. First time only. First time I came. Only first time going on. One more function is called. Now I am doing A is postponed. A is waiting in the stack. Now I am doing B work. Let's come to B now. Same story repeat again. What is the B? First step. B first step. Visited of B is equal to 1. Recursion means what? Same work you should do again. Visited of B is equal to 1. Okay. Let's go there. B is 1. Print B also. I printed. So first step is over. Second step is over. Can you see everyone? First step is over. Second step is over. Can you see the third step? For all W adjacent to B. Can you see the graph and talk? For all W adjacent to B, who are those? AE. AE. Remember, it is the first W, it is the second W. Right? Now take the first W. First W is what? A not visited. See the first step. Right? Fourth step, see. A not visited, visited. A is already visited. That is the reason, right? This is cancelled. This is done. Remember, this for loop should be 2 times, 1 time over. Let's go to second time, right? E. So E not visited. Can you check? E not visited. Yes, not visited. If not visited, yes, true. Then fifth line. DFT of E is called. DFT of, when you say DFT is called recursion, again same story. Now it's a correct time to ask you, who is the first person called? I want answer from all of you. Who is the first person called? What is the first function called? DFT of A. Am I right? First person called, DFT of A. Remember, called means push also, visited of that person also 1 and print also. Am I right? When you call, it will push also. See in the stack available. It will push also, it will print also. Visited of that person is 1 also. And one more thing, A called first, okay. Is he completed or waiting? A called first, okay. E completed or waiting? A called first, I am happy. But E completed or waiting? A story over or waiting? Waiting. E is still waiting. See, in the A, fifth line is not completed. Third line also not completed. In the A, third line is not over. See, third line means what? For loop. For loop is not over. Fifth line also not over. To complete that, I called B. Again, in the B. Listen, when you called B printed also. B visited also 1, so that you no need to print again. And right, and one more thing is, it is a waiting. So B is waiting for E purpose. B is waiting for E purpose. So in the stack, first A is waiting, next B is waiting, next E waiting. See, everyone know. What is the DFT? Everywhere take 1. See, I took here 1. See this one, 1. So A is taken 1 person B. Remaining people are waiting in the stack. A is taken 1 person B is going further. Remaining people saying, what about us? So A saying, right? So I am taking now B, I am going further. You both people wait in the stack. I will come back. In the backtracking, I will finish you. So now B again, same story. Whenever I am at B, one person only there, right? 1 person completed, 1 person only there, happily is going. Now I am at E now. Again, see, E adjacent is 3 people. B also, C also, G also. B also, C also, G also. Let me write. E. I am at E now. First step. Visited of E is equal to 1. Okay. Print E also. Okay. 2 lines are over. 2 lines. Can you see the third line? For all W adjacent to E, if you observe, what is the answer? B also, C also, G also. Any order you write. Adjacent to E is B, C, G. Any order you can write. P you can write, G you can write, C, any order. No objection at all. But see the fourth one. First W is B. B not visited, B already visited. So cancel it. Next G not visited. If not visited, true, then fifth line, call G. Recursion call DFT of G. Right? Remaining people are waiting. So G purpose I went. Remaining people are waiting. So until now, I am at G now. So if you want, you can verify. See this one. Is there any backtracking till now? Stack size is keep on increasing. Any backtracking till now? Backtracking means pop. Till now, any pop. Every time is calling. Stack size increasing. First A called, next B called, next E called, next G called. Calling only. Calling means push operation. Push operation means stack size is increasing. Whenever pop happened, stack size will decrease. Till now, no pop. Let's go to G. So first G first step. Widget of G is equal to 1. Second step, print it. Printed. Third step, as usual, third step. For all W adjacent to G, can you go to the graph and check? Adjacent to G is E and F. E and F. E and F. E already widgeted. If you want, you can check. E already widgeted. So F only. Let's see the F. Fourth line. F not widgeted? Yes, not widgeted. Then call recursion. F not widgeted? Yes. Then call recursion. DFT of F. So remember, till now, no pop operation. So DFT of F is called. So if you observe clearly, see this one. If you observe clearly, everyone observe. First A called, next B called, next E called. It is a stack. This is the stack size E called. Next G called. I am at G now. Currently I am at G now. G called F also. I am at F now. Current status is FC. In the stack is the first person, second person, third person, fourth person. It is the fifth person. In the stack, fifth place, F is there here. Now again, same story. Can you see the first step? Widgeted of F is equal to 1. Second step, print it. Third step, see the third step. For all W adjacent to F. Same story here. Recursion means nothing bad. Recursion means nothing. You are doing same story. Who is the F adjacent? F adjacent G also, C also, D also. These three people write any order. G, D, C, any order. G, D, C. But do you believe or not? G already widgeted. So not required. D not widgeted. D not widgeted. So see the fourth line. D not widgeted. Okay. See the fifth line. DFT of D. Now very important thing is going to happen. Please be careful. I am at D now. F called D. F called D. These are stack units. First A there in the stack. Next B there. Next E there. Next G there. Next F there. Next D there. Now top of the stack is a D there. Almost everything is ready. Now can you see the first step? Widgeted of D is equal to 1. Widgeted of D is equal to 1. Next one, D printed. Second line also, everyone observe here. It's a very important one. Third one, for all W adjacent to D. Adjacent to D if you observe. Adjacent to D if you observe AF. Everyone observe. Adjacent to D is AF. Listen everyone. Adjacent to D is A and F. Now see the fourth line. Is A not widgeted? No, widgeted. Check if you want. A already widgeted. Next one. F is already widgeted. Yes, already widgeted. See. Somewhere F is there. So in the third step, right? For all W adjacent to D, two people, they are already widgeted. Means you are unable to call the fifth statement. Fourth one true, then only I will go to fifth. Fourth one true, then only I will go to fifth. So in the story, you are not calling fifth line because condition is not true. Fourth true, if A not widgeted already. F not widgeted, already widgeted. So no one is calling the fifth line. And one more thing is this for loop is over also. 1, 2, 3, till now 3 not over. In all the previous function call, if you observe, 3 not over, for loop not over. Now for loop is successfully completed. And no one is called also. That indicates, listen, that indicates this D function, right, able to see closed bracket. See, D function able to see closed bracket. Until now, you are unable to come here. Every time you are going, until now, at this place only you are going back. At this place only you are going back, you are unable to come here. You are unable, if you come here, then you will go here. You are unable to come here, you are unable to come. Now you are able to come. First time you are able to come. This is called backtracking. Now pop. This is popped. Completed. This is popped. Listen, this is popped. That means, listen, that means you are at D now. You are at D now. It is popped means you move to here. You are at F. That is the meaning of backtracking. When you pop, you will go to previous function. So I went to previous function. What is the previous function? F. I am inside F now. D completed. D popped out. I am inside. How inside? Inside where? See this one. Inside here. For this purpose you came. Now this is completed. Now see there. Now see there. Now this third line is asking for every W. Now W is C. C not visited? Can you check? C. C nowhere there. C not visited? Yes. C not visited. Then call C. Here you are calling DFT of C. Previously you called DFT of D. Now DFT of C. Again recursion. After one backtrack you are calling. After one backtrack means you will go here. You are calling again C. C called here. So now you are at C now. Can you go to C? First line. First line. Can you go to C? First line. What is the first line? Visited of C is equal to 1. Okay. Print C. That is also okay. For all W, see, for all W adjacent to C. Adjacent to C, who are those? Can you see the graph? Adjacent to C, A, E, F. Let me check. Adjacent to C is A, E, F. A, E, F. Do you believe or not? A already visited. Do you believe or not? E already visited. Do you believe or not? F also already visited. That means this third step completed. Third step is over means inside 4 and 5 also over. Don't worry. Because every time 4 coming, completed. Every time 4 coming, completed. Every time 4 coming, completed. You are unable to go to 5th line, means successfully completed. You are able to see closed bracket. That means this also popped out. When you say popped out, you are backtracking. So now you are at here. Previously here, you backtracked, you went. Now again you called, you backtracked again here. So again here means previous function. Now C also completed. That means this W over. So this function successfully completed. In which function you are, this is successfully completed means it is popped out. F popped out. F popped out means now you will backtrack here also. I am at here now. Right? F popped out means you are in this function. In this function now. In this function where, see this one. This F purpose you came. Now this is over. When you say it is over, what purpose? This purpose only I am doing. This is over means F over. That means this third line is completed. In this total over. So G function also completed. So G function also completed means you will go back. You are at here. G over means G pop. G pop, then you are at E. In this function you are. In this function, see this one. G purpose you came. Now G over. Then ask the C. C already visited or not? C already. That time it is not visited. When you are backtracking, someone which is not completed previously, now it is completed by someone. C. So when I ask now, right, C is already completed or not? Now it is completed. Someone is completed. Then what is the answer? It's work over. This third step is over means this function completed. So which one? E. E also backtrack. E backtracked, so you will be here. Remember, backtrack means pop operation. This also done. Now, in which function you are? B. B function. In the B function, E purpose you came. E over means this is completed. Then B also popped out. Then B also popped out means you will go to A. Now I am at A now. Now I am at A now. In the A, see the interesting answer. In the A function, B purpose I came. It is completed, then go for the C. Interesting thing is C visited already. That time not visited. That time is not visited. Now someone is visited, completed. That time it is not visited. Now someone is completed. So in life, sometimes you will get some options. If you don't take, and if you go somewhere, if you come back, those may not be available. Am I right or not? So B purpose I went outside, C and D is waiting. When I come back, C and D is covered by someone. Am I right or not? At some point of time, you have three options B, C, D. At some point of time, you have three options B, C, D. You took B and you went. You took B and you went. Because of some reason, you came back, C and D saying, we are already gone. C and D over, right? C and D saying that we are already completed. That time we give an offer, you didn't utilize. It is something like this. It is something like this one, right? It is something like this one. 3 girls are proposed to Ankit. Ankit, 3 girls are proposed, G1, G2, G3. For Ankit, 3 girls proposed, G1, G2, G3. So he said to, right, first girl G1, he said to first girl G1, okay. So Ankit and first girl, right, so they are going and they are dancing, something like that. Finally, that G1 girl beaten Ankit. So Ankit didn't say anything to G2, G3. G2, G3 asked, Ankit, how can you ditch us? G2 saying, what about me? You are going with G1, what about me? G2 is asking. He said, he don't have any reply. G3 also asking, what about me? He don't have any reply. So they are waiting. He went with G1, he is dancing with G1. So afterward, G1 beaten him, he came back. He came back and is asking, hello G2, previously you called me. What about now? Then G2 saying, just get lost. Just get lost. Then he asked G3, hello G3, at least you. G3 saying that I will slap you, get out. So what I mean to say is that time they are available, but if you come back, they may be available, they may not be available. So B purpose, you went outside, when you come back, C not available. How you know my story? Is it true? Is it true? G1, G2, G3 means, G1, G2, G3 means, right, goat 1, goat 2, goat 3. 3 goats are waiting, not girls, goats. 3 goats are waiting. Bhaiya, G1, G2, G3 means not girls, bhaiya, goats. 3 goats are waiting. 3 dogs waiting. Correct, goat. Wait, anyhow, we are in the middle. Can you come back? We are in the middle. Can you come back now? So these 3 over, that means this 3 is completed. That means, listen, that means this A is popped out. That means that A is popped out means, so this A also popped out. So remember, going is, right, see this one. Going like this is push operation. Coming back is pop operation. When you come back, it's a pop operation. So like that. I think you got some rough idea. I think you got some rough idea. Some people are asking, sir, what is the name of this tree, sir? Remember, name of this tree. Name of this tree is called DFT tree. This is called DFT tree. Coming. This is called DFT tree. What is the stack size? Stack size 1, 2, 3, 4, 5, 6. In the last slot, first D came because of backtrack, next C came. So 6 units of stack. They will ask in the exam, right? How many units of stack? For this answer, 6 units of stack. Okay? Is it fine? Is it fine now? Is it fine now? DFT, is it fine now? From here, DFT. Sir, can we write else? Yeah, do whatever you want, right? Fine. Yeah, you can write also. Fine, this is the one. So some people are asking how, sir, how the program for a DFT? Sir, for a DFT, how program? This is the program. Some people are asking, sir, how program? This is the program. Sir, how it is running? This is the running. This is running. How this is running? So calling means push operation. Calling means push operation. Further calling not possible. See here further calling not possible. Backtrack, pop operation. Here further calling not possible. Backtrack, pop operation. Here further calling not possible. Backtrack, pop operation. So these pop operations are going like this. Whenever no other chance, pop, backtrack. Whenever no chance, backtrack. Right, like this. See one time and come tomorrow. Most probably tomorrow graph traversal will be over. Tomorrow, most probably today itself, it could have been over. One dog kept finger in my class. Today itself, graph traversal could have been over. One dog kept finger inside my class. That is the reason 1 hour lecture is pending. That is the reason 1 hour lecture is pending. One dog, literally not one dog, 3 dogs. 3 dogs. Dog number 1, Ankit. Dog number 2, Amartya. Dog number 3, Sunny. 3 dogs literally kept finger in my class. That is the reason 1 hour it went a little extra. 1 hour went little extra. 3 dogs, not 1 dog, 3 dogs. Literally 3 dogs. So please revise this. Please revise this. Come tomorrow. Right? Tomorrow, I think at this time, everything is all right. Everything is all right. Tomorrow, this time, everything is all right. Fine. Chalo then. Bye. Good night. Good night. Everyone revise, come. My request to everyone, revise first and come. My request to everyone, revise, come and revise and come. Don't come by dancing. Don't come by dancing, revise and come. My humble request to everyone, revise and come. Don't come by dancing. Fine. Thank you. Thank you. It will be very useful for GATE also, placements also. Everywhere it is very useful. That is the reason I done that much deep research. So much deeply I am explaining because it is asked many times. These questions are from graph traversal asked many times. It will be useful for placements. GATE most importantly every time 1 or 2 questions will come. 1 or 2 questions will come. Please take care. Thank you. Good night.